Hi. Alright, now let's look at these examples. Is involving the applications of arithmetic or geometric theory. Okay, let's look at the question. How was the question decide that you need to decide whether they are arithmetic or geometric, right? So a pendulum swing through an arc of 40 cm, right? You know what is pendulum or not? This is the pendulum, right? You're doing your science experiment, so you're doing the pendulum. So the first you have swing, then the swing will be the swing arc of a 40 cm, right? So when you release the object which has mass, so they are swing, right? They're swinging, so they will reach a maximum height, then they will swing back. So 40 cm on each successive swing means this is the first swing, right? So when it come back, it become the second swing, right? Third swing, fourth swing, fifth swing, sixth swing. So now the question on a successive swing pada ayunan seterusnya. So the length of the arc is 0.95 of the previous length. Means that firstly you have 40 cm, right? 40 cm. So this is your T1, your A, first term. So if you keep swing, you go here. Of course, when you came back here, because of the air resistance, right, that you learn in physics or science, they will reduce. It will be this in this way. Try to imagine a bit. Later come back, shorter a bit, getting shorter, swing. Alright, then they will stop somewhere, right? They will stop, okay, at one time. So you have to, if you do this experiment, you will understand this problem, alright? This problem, 40 cm, 0.95 means it's less, right? 0.95 is less than 1. So means that if you multiply, you take 0.95 multiplied by 40, you have 38 cm, right? You have 38 cm. Means that the first swing is 40 cm, and when you swing back to the, they won't reach this location here. So they will reach lower than this, which is 38 cm. So if you keep multiply again, 0.95, okay, for the successive swing, so you have 38 multiplied 0.95, you have 36.1, right? Getting lesser and lesser. So if you keep multiplying, but 0.95 is very slow. If you keep multiplying, it takes very long for the swing to reach nearly zero, no swing at all. So this type of case is what type of case? Is arithmetic or geometric, right? You see, we multiply, right? 0.95 of the 40, 0.95 of 38. This is an GP problem, right? This is a GP, geometric progression, okay, geometric sequence. So since you know that this is a geometric, so you have to know what formula to apply. So the formula here will be, for the n term you have AR to the power of n minus 1, and for the Sn you have A Rn divided by 1 minus R. And for the sum to infinity, for geometric series, you have an additional formula here, is the sum to infinity, right? This may involve sum to infinity because why? The swing is taking too long, right? First swing, third swing, so you will feel sleepy when you see the swing, right? It take very long. It will take very long to finish the process. So now, okay, we look at the question. So what is the first term here? First term here, you know, is 40, right? 40 cm, and the common ratio is 0.95, which is given in the question, right? 0.95. So the question said, what is the length of the arc after the fifth swing? Means that 1, 2, 3, 4, 5, the fifth swing, means that the T5 here, right? Clearly is the T5. 1, 2, 3, 4, 5. Okay, so the fifth swing. So you apply the formula A 40 n minus 1. You take 5 minus 1, and your R here will be 0.95. Okay, 0.95. So you're taking 40 multiplied by 0.95 to the power of 4. 40 minus 0.95 to the power of 4, which give you 32.6, okay, around 32.6 centimeter, right? So this will be so you can answer back the question by writing a sentence here. You can say that, therefore, the length of arc after the fifth swing. So the question should say at the fifth swing. At the fifth swing, it will be 32.6 cm. Alright? 32.6 cm. So, okay. So the first A, I already answered for you. So for part B, at which swing? This is the first A. So the B here state that at which swing? Ayunan keberapa means Tn. They want to find the value of n. Are the pendulum is of the arc of the pendulum. The arc here refers to Tn, right? Because Tn represent the length of the arc. So at which swing means find the n. Less than 15 cm for the first time. For the first time, less than 15 cm, right? So you know the formula for A, right? The A is 40, R is 0.95 to the power of n minus 1. This is what they want. Alright, when does the n less than the 15 swing? So I have 0.95 power of n minus 1. I take 15 divided by 40. Okay, 15 divided by 40. You have 0.375. Alright, as usual, you put log both sides, right? Because this number, they don't have the same base. So you put log 0.95. Alright, log 0.95. The power of n minus 1 here is why, that's why I learned, I put the log to bring down the power. So which is less than log 0.375. Then you have to know that this is actually a negative value, right? A negative value if you key in. So once you divide this to this, you have to change the sign. So you have log 10, 0.375 divided by base 10, 0.95, right? 0.95 and 0.375, you have 19.1, right, around. So n is greater than 20.1. So means after n greater than 20.1, the swing will start to less than 15 cm. Alright, so which is the swing that start, at which swing is the length of the arc of the pendulum less than 15 cm for the first time? Means that during the 19th swing is still greater than 15. Means after 20, more than means after 20 means the 21st swing. Okay, the 21st swings. During the 21st swing, the length of the arc of the pendulum is start to less than 15 cm. Alright? So this is how you answer this part of the question. Okay, now you can pause the video and try to look at how to calculate the value of how to solve the problem for C, right? For C. So this is an experiment, right? So you using mathematics to help you to calculate. So just now you know that your first term is 40 and your common ratio is 0.95. Okay. Let's look at question C. Part C. Right? Okay, part C. Find the total distance. Find the total distance covered by the pendulum after 20 swing. Right? Covered by the pendulum after 20 swing. Means that after 20 swing means that S20, right? Because means that before 21st swing, so there are total 20 swing. So means you need to calculate the 20 here, right? So means find the total distance covered by the pendulum after the 20 swing. 20 swing means, okay, you take up 40 plus with the second swing, and you keep adding up to the 20 swing. So this is the first 20 swing, right? If you add up everything, you will know the total length of the pendulum that are already covered. So S20, so very clearly you use the formula for Sn. You need to know that you need to use this formula, right? Because it's involving sum, right? You add up all the length. So Sm is A 1 minus Rn over 1 minus R. So your A in this case is 40. 1 minus 0.95 to the power of 20 over with 1 minus 0.95. Very easy, right? It's easy if you understand the question and you know how to apply the formula. So 40 bracket 1 minus 0.95 to the power of 20 over 1 minus 0.95. You have total of 513.2 centimeter. Alright, 40, 38, 36, keep on adding until the 20th swing. You will total have 513.2 cm. Alright, so hope you understand. And now we're looking at D, right? So find the total distance covered by the pendulum before it comes to stop. It's very different. It's very different from this question. This question they said about find the total distance covered by the pendulum also, but after the 20 swing. So means the before, okay, before the after the 20 swing means that before they already move for how long, right? So means they already move for 20 swing, right? 20 swing. So for D, find the total distance covered by pendulum before it comes to stop. Means that when will it stop, right? First you have so it means that it will keep swinging very long, take very long. So when people asking you, hey, when will the pendulum stop? Do you go and calculate, right? You not even can see what is happening there, right? So you will see that. Firstly, you can see clearly, but when the time go for very long, you will don't know when they will stop, right? They will become static. Oh, this is very hard, right? So for this case, very long, we talk about S infinity, right? After very long, because after very long, the value here, the value of this number is converged, you know. You add up, you will converge to a value where the number getting smaller and smaller, right? Nearly zero. So very easy lah. You just talk about sum to infinity. Before it comes to stop means very long, take very long to stop. So your A is 40 divided by 1 minus 0.95. Okay. So let's calculate and see. 40 over so you have 800 cm. It's predicted that you have already moved up to 800 cm. Of course, it's greater than this. This is for the first 20th swing, right? So if you get for very long, this is a total that the maximum, okay, covered by the pendulum is 800 cm. Alright, that's all for this video.